Alright, welcome back to Class 5. Um, today we're going to talk about a few things. We're going to talk about some more I/O. We're going to talk about how to ingest from a file and also how to output to a file. So we know how to read from standard in using scanner, and we know how to write to standard out using system.out.println, and we're going to find the parallels for those for doing file I/O. So that's going to be one of our goals today. And the second goal is to talk about hashes. And hash tables are built into Java. They're a class that we can freely use. So we're going to look at how hashing works in Java, and this is going to give us a really good tool set for starting to build some interesting programs. So let's begin with reading from a file. Go into my 223 account. I'll make a new directory for class 5. And I'm just going to work with a class called main, so we'll do main.java. And so we're going to use the scanner class as usual. So let's pull up the documentation for a scanner. And remember, when we constructed this, we said new scanner parentheses system.in. But we have another way to construct a scanner. We can specify a file, right? And so we can create a file object, an object of type file, associated with an actual file on our hard drive. And if we look at the file class, we can construct that by simply giving a path name for the file that we want to read. So we have to get file from java.io, we have to get scanner from java.utility. So let's go ahead and do some imports. And with imports, you can use wildcards. I could say java.io.asterisk or java.utility.asterisk, but it's nice to be kind of as specific as we can when we import these things, so that we're not pulling in a lot of extra classes that we don't need. So let's go ahead and open the file test.txt for reading. So I'm going to create a scanner object. I'll still call it SC for no particular reason. SC equals new scanner, new file, data, or test.txt. We're going to try to open this file so we can read from it. And then we're going to use our usual loop that we use for reading from a scanner. We're going to say while sc.has next line. And we'll say input equals sc.next line. And then we'll just go ahead and print out what we just read. So we'll just print out input with delimiters around it. So we just read the line such and such. And then when we're done, we'll just print out a message saying we hit the end of the file. And so this is a good start, but when we try to compile it, we're going to get that old error about unreported exceptions. So when we construct a scanner with system.in, like this, there's not expected to be an exception. But when we construct a scanner using a file, it's possible, for example, the file won't exist, or we won't have read access to the file. And so this construction could throw an exception. And so what do? We put it inside a try-catch block. Now I declared scanner up here, so I can put my try-catch block here. And again, I'll just catch, any exception that happens. And I'll say error opening test.txt. And I'll return from here. And this is something that makes code easier to work with, right? I don't want to put all of this code inside the try block, right? Because then I've got to remember what block am I inside. And I don't want to set a flag here and say if that flag's not set, go ahead and do all this stuff. If I get an exception, I can't open the file, I'm out of here. I just want to exit the program. I'm just going to say return right here. And returning from our main method, that takes us out. So now I don't have to indent this. I don't have to put this in an if statement or anything like that, right? If I get to this spot in my program, I know that I succeeded in opening that scanner on this file, and I should be good to read it. So let's compile that. And let's go ahead and run it. And I get the message error opening test.txt. Well, why is this? Because I don't have a test.txt. So let's make one. Alright, so there's a file with a few lines in it. So now if I run my program, it succeeds in opening the file, and it says we just read the line, this is a test, there's stuff in this file, there are typos, and so on and so forth. And at the end of the last line, the next time it says has next line, it's going to get a false, and so it knows that the file hit the end, and so it says end of file detected, goodbye. Alright, so a couple of details. This scanner class has a close method associated with it. And if the scanner is reading from a file, we can call the close method to close that file. Now on Linux doesn't make a big difference, but on some operating systems, if you have a file open, another process may have difficulty interacting with that file. So we can go ahead and call close just to keep our code nice and clean. So let's go ahead and do that. So I'll call close here. And it doesn't do anything obviously different, but if we did not exit the program down here, if we did something else, if we went into a long loop or something, we could actually detect that that file was still open, and that's using up resources and so on. So that's the basic strategy for reading from a file. The other thing I want to mention is that with scanners, we've mostly used has next line and next line to read in one line at a time, but there are other things we can do. For example, we can say read the next byte, read the next double, read the next integer. We can read things other than just an entire line of text ending with a new line. In the same way that, we can use scanf to read from standard in. I don't think there's a need to do that, at least with what we're going to be doing in this course. I think it's cleaner to read an entire line and then break it up separately, right? So read in your line with next line, and then you can break it into pieces with split or whatever, and then you can parse it with, integer.parseInt and so on and so forth. But there are a lot of things we can do with a scanner object. All right, so that's our basic input system. So the next question is, how do we output to a file? And when we say system.out.println, whatever we send here goes to standard out. Now I could also redirect standard out into a file, and now I've got a file called output that has the output of that command. But sometimes we want to actually write a program that by itself will write output into a file. So let's do that. So let's copy this output into a new file. Alright, so to do that, we're going to use a class called printWriter. And printWriter also comes from java.io. And to construct a printWriter, we can again use a file. And that file can be constructed from a path name. And that will create an output stream. And then we can use methods like, guess what, print and printline. So we can printline a string or other types of things. Mostly we're just printlining strings. And instead of saying system.out.println, we can say our printWriter.println, and it will write it to the file. And in this case, closing the file is going to be important at the end because output is buffered. And also, if we want to force the output to appear before we close it, we can say flush, and that forces the output out of the output buffer and actually into the file. So let's go ahead and create a printWriter in the beginning. So let's go ahead and open the file first. So, terrible comment, but create a printWriter for writing into. So I'm going to say printWriter pw. pw equals new printWriter, new file, and I'll call this file copy.txt. Alright, so when I compile it will complain unreported exception on trying to create this printWriter, must be caught or thrown. So I'm going to put my printWriter constructor inside a try-catch block. And I can just copy my catch block. So I'll say error creating output file and I'll return. Otherwise, PW should be a printWriter. And then down here, if in addition to printing this out to standard out, I can say pw.println and I'll just print out input. And then at the end, I'll close the scanner. And I'll close the printWriter, and that should copy the file that we're reading, test.txt, into an output file called file copy. Alright, so I've got my test.txt. I don't have an output file yet, so let's compile this, and let's run it. Let's run it. And it looks like it did the same thing, but it's created a new file called file copy. And if I look inside that, it's a copy of my original file. So that's all the I/O we need for this course, really, right? Using scanners to ingest, using printWriters to output. And that's going to work for file I/O. It's going to work for network I/O. It's going to work for most things that we want to do in this course. Now there are a lot of other ways that we can do I/O. There's different types of streams. There's buffered streams. There's raw streams. There's high level and low level ways to do I/O. But for what we're doing, this gets us on the air. This is good enough. So again, if we look at the code, basically use a scanner to read from a file and use a printWriter to write to a file. And when we want to ingest, we use the scanner's hasNextLine and nextLine methods. And when we want to output, we can use the printWriter's printline method. And then close these at the end, and we're done. Alright, so that's the I/O stream. let's talk about hash maps. So if you remember from 224, we talked about associative arrays. 222, we talked about hash tables. And the basic idea here is the notion of key value pairs. So we can think of data that comes as a pair of things. For example, a name and a phone number, or a word and its definition, or a piece of music, the title of a piece of music, and a signature that is unique to that particular recording of that music. So there's lots of things we can think of as these key value pairs. And the idea of a hash table is we can say put, and we can give a key and a value. And when we do that, it stores this pair inside the hash table, and then we can say get whatever is associated with that key, and it will return to us the corresponding value. So if we want to make a dictionary, which you'll do in the practice problems for today's lecture, each time we get a word and a definition of the word, we can put that into our hash table, and then if we want the user to be able to look up words, we can say, tell me what word you want. They'll type in a word, biology, and we can just say get biology, and it'll return the value associated with it, which is the definition. So we did this in 222. You actually created a hash table yourself. You made a hash function. You made an array of linked lists, and your hash function took a key, decided which linked list you should store your key value pair in, and then put them into the linked list. In Java, again, hash maps are built in. So let's take a look at HashMap. So it comes from Java utility, and we can construct it just with no arguments, just new HashMap. But we can also specify a capacity, right? How many things we're going to store in the hash map, initially 16, and also a load factor, which tells us how full does the hash have to get before it rehashes and makes the table bigger. So we'll usually just construct a hash map just with no arguments. And then a variety of methods, but the main two we're going to start with is put. We put in a key and a value, and get, which takes a key and returns a value. So this is a really, really powerful class, right? This is going to let us do a lot of things without having to write a lot of code. It's going to give us a really convenient way to store pairs of pieces of information. Now, hash maps are generic. And, linked list was generic. We had that angle bracket E, that parameter, which says what kind of thing is in our linked list. With hash maps, we have two things we have to specify. What type of thing is the key and what type of thing is the value. And those don't have to be the same. So we'll do an example where we use two strings. But, it could be a string and an integer. It could be a string and a linked list. It could be, a string and another hash map, or an integer and a linked list. It can be anything we want. So let's play around with hash maps a little. So I'll make a hash test.java, and let's do some imports. So we'll import Java utility HashMap. All right, so I'm going to do a hash map where the key and value are strings. So I'm going to say angle bracket string, comma, string. And I'm going to call my hash map just map. And I'll make it equal to new hash map. And I have to, over here in the constructor, specify the types of objects that the key and value pair are. And I'm not going to use any arguments. All right, so that's enough to compile. Right, I can compile hash test and it'll compile fine. It won't do anything, but we haven't done anything wrong yet. All right, so this is going to make a hash map. All right, so let's store some things in here. So I'll say map.put. And let's just put some things in here. Hello. Goodbye. So I'm just throwing in a few words with some definitions. All right. So this will create, you know, in the memory of the Java virtual machine, a data structure that associates with each of these strings, these corresponding strings, right? Now we could do this in C. We could do it with parallel arrays. We could just make an array of strings, and an array of strings. When we want to search for something, we could just check each of these to see if it matches, and then find the corresponding definition. Or, you know, we can make a hash table the way we did in 222, but this is built in for us, right? So let's play around with the hash. So let's print out the size. And I'm just going to use the size method, which, you know, not a whole lot to it. It just returns the number of key value mappings in this map. So let's pull out a value. Value associated with car is, and I'll just do map.get car. All right, so let's just try this. Compile it. This is map, not hash. Compile it. We'll run it. It tells us the hash is 5 and the value associated with car is a means of transportation. So this is successfully storing this information. Let's go ahead and make a little interface here where you can type in a word and get the definition. So let's make a scanner for reading from system.in. So, well, the scanner has an X line. Let's read the next line, save it in string, and let's print out map.get word. All right, so we'll prompt the user for a word initially. Let me do it like this. All right, we'll open a scanner. We'll ask the user for a word. We'll wait until they type something. We'll read in that line. We'll save it in Word. We'll call the get method on our hash map with word, which should return a string, and we'll print that out. And then we'll prompt the user for another word. And at the end, when we hit Control D, we'll just go ahead and exit. So let's compile this. And I forgot to include to import a scanner. So we'll import that, compile, and run. So enter a word car, that's a means of transportation. Enter a word, I don't remember what my words were, phone, that's a communication tool. And if I say enter a word and I say frog, it gives me back null. So let's take a look at this get method. When you say get and you put in an object, returns the value to which the specified key is mapped, or null if the map contains no mapping. So we can make this a little nicer. First of all, when we prompt for a word, let's not put out a new line. And when we get the word, instead of printing it immediately, let's say string definition equals the word, and then we can say if def equals null. We'll say word not found, else we'll print out the definition that we got. Right, so now if we ask for a word that's not in our hash table, we'll get a nice message saying word not found. Otherwise, we'll go ahead and we'll print out the definition. So compile that. Oh yeah, and in C, null is all uppercase. In Java, null is all lowercase. Alright, enter a word. I can say car, it's a means of transportation. I can say phone. I can say hello. I can say frog, and it says word not found. So we've got a nice system here. And if I hit Control D, it takes me out of there. And the other thing I'll mention in here is that this thing, sc.nextLine, really is a string, right? NextLine returns a string, so I can store that in Word, but I don't necessarily recommend doing this, but this is totally legal. Right? I don't necessarily need these temporary values. If there's a new line available from the scanner, I can call this, which returns a string, and I can use that string as an argument to the get method of this map object, which is an object of type HashMap, right? And it all gets put together correctly. And so this should work exactly the same as before. And, you know, in this case, I would like to have a temporary variable. I'd like to take this next line and store it in Word so I can remember that's the word the user is asking for, and maybe I want to print it out down here next to the definition. You know, the definition of blah is this. But we want to recognize that we can put these things together like this, and this is going to be really powerful, a really useful way of thinking about how to put some of these methods together to do the things we want to do. All right, so that's the basic of HashMaps. There's one more detail I want to go over. When we have an array of information, we can output the contents by just making a loop. Just start at the beginning, go all the way through to the last element, and, you know, for example, print out each element. When we have a linked list, we can start with the first node after the sentinel and print it out and move down the list and get to all the data like that. And with a hash map, so let me take out some of this code here. I can do this. I can print out the map by appending it to a string. And this will call the toString method of this object. And since this is a hash map, the toString method will do something pretty useful. Right? It will tell me my map is, and it will show me a set of key value pairs with equal signs in the middle. So car equals a means of transportation, comma, phone equals communication tool, and so on. So if I just want to see everything that's in my hash map, I can do that. But if I want to do anything more nuanced, like pulling out the elements one at a time, I have to do something a little more interesting. And this is where we're going to get into the concept of an iterator. So the idea of an iterator is to set something up kind of like a scanner that will let us move through the elements of our hash. The thing that makes a hash different from things like a linked list or an array is that, if we don't know what the keys are, we can't say, okay, give me the element associated with hello, goodbye, car, and so on. And there's no natural ordering to these. There's no first thing, second thing, third thing, and so on. So we're going to use what's called an iterator, and we're going to create an iterator on what's called a key set. So I'm going to use the key set method as follows. And key set will return something called a set. And a set is a generic, and so it takes a type parameter. And so even without reading any of that information, I'm just going to say set angle bracket string map key set equals map dot key set. All right, so I'm going to call the key set method. Right, and it's going to return something of type set, where I've specified that this is a set where the elements are strings. So we don't necessarily know yet what exactly this does, but it should return something in this object that's associated with each of the keys. In other words, hello, goodbye, car, phone, and hash. And when we look at a set, we see that a set has something called an iterator method, which returns an iterator. So let's go ahead and get an iterator on this. And it's going to be an iterator over a set of strings. So iterator string it equals map key set dot iterator. Alright, so let me add some comments. This is a set of keys from the hash table. This will let us iterate over the keys. Alright, so how does an iterator work? Well, it.hasNext string key equals it.next. All right, so we can look at the documentation on an iterator, and basically it's got a couple of methods, hasNext and next, that we're most interested in. HasNext returns true if there's elements in the thing we're iterating over that we haven't seen, and next returns the next element. So what's this going to do? It's going to take this hash map, which has these 5 keys stored in it, and this is going to return what's called a set. It's a collection of keys, right? A collection of strings that contain these 5 things. And then this is going to take that collection and create an object called an iterator. And that iterator will have a pair of methods, hasNext and next. And the idea is each time we call hasNext, it will say, hey, is there another key in here that you haven't seen yet? And if there is, hasNext returns true, and next returns another key. And so this should loop over all 5 of these words, hello, goodbye, car, phone, hash. and then the sixth call to hasNext will return false, and we're done. So compile that, and we also need to import iterator from Java utility. And let's see where set comes from. Set comes from Java utility also. And again, you know, we could wildcard Java utility asterisk and get all of these, but let's keep it kind of nuanced and just specific to the things we actually want. All right, so cannot find symbol map.keyset. Let's go back to our hash table. And keyset has an uppercase S on it, so my bad. All right, so we run that, and it says the next key is car phone, goodbye, hello, hash. And you should note that even though I created my hash table with hello, goodbye, car phone, hash, the order in which the iterator gave me my keys is different, right? It gave me car first, followed by phone, followed by goodbye, which is not the same order I put them in. So there's no guarantee on the order in which a hash map will return the keys to you when you iterate like this. But it will give you each key exactly once. And you know, if I wanted to just dump my dictionary, I could do something like this. So I can say the next key is key and the definition is, and how do I get the definition? Just map.get parentheses key. So now when I run this, I get my entire dictionary, and it says the next key is car, and the definition is a means of transportation. The next key is phone, and the definition is communication tool, and so on. Yeah, I typoed communication. So there we go. That's a hash map. And you can see just a few lines of code, and we've got something pretty powerful already, something that took quite a bit of work in 222 to put together. And this is a few lines of code in Java. So so that's the basic setup with hash maps. As usual, you can read lots of information about this in the beginning of the documentation page, including how this responds to having null values. And if you have a null key or a null value, you need to be careful with that, because there's hash maps and hash tables. Hash maps permits nulls, hash table does not. But we're not going to worry about nulls for now. So anyway, that's the basic setup for hashes and for file I/O. And in the problem set, you'll get to work with this and build a dictionary that reads an input file and then lets the user query definitions. All right, I will see you in class. Thanks.